So we're still going over subnetting, correct, today?
Yeah, I will still, we still have time. We'll go over subnetting tonight a little bit, and then we'll do a review. We'll wrap up with a review, because I figure that'll be the last thing we do is to wrap up with the review. But we'll cover subnetting. So we're doing it a little early, but I figure there's no amount of time that you can't add on subnetting, because it's a difficult subject matter. And so we would normally start it when we first get back from spring break, but since, like I said, we had a lot of extra time, I'll at least cover it a little bit. So if you go into the week 9 section under lessons, and week 9, there is an IP address subnetting workbook, student version 2. What's that? Yes, it is.
Oh, it is.
Yes, some of you that have had me in prior classes know this from extra credit, but you were assigned a small portion of this. You are in networking, so you get to do the entire packet. Yes, I see all kinds of yays. Oh, it's not bad. Okay, so there are, as it says, 85 pages. Let me download this. Yeah, there are 85 pages, but yeah, if you download it.
So it's really like 82 pages.
Yeah, it's not even that, because there's a lot of instructions and a lot of examples. So
More around like 60 pages.
it could be, right? So, but you're only assigned on the packets page 15 to 78. In Adobe, it would be page 17 to 80, because there's 2 title pages that it doesn't count, right? Or yeah. So we'll go through it, but download it. You put it in Adobe. It's the best way. You can edit it here if you want, or you can print it out, but you'll have to print it out somewhere else, not here, because we don't have enough paper for you to print it out. But you could go to the lab. I think you can print it in chunks, but 25 pages at a time. Yeah, per week. Okay, well, what's that? You can print it out at work. Yeah. Well, it's technically gets assigned week 9. It's due just before week 14. So you have several weeks, and then I'm letting you know about it now. So you have even more weeks. So if you just printed off 25 pages each week and did 25 pages a week, you'd actually be in good shape. You could actually get it done. So, so like I say, this first page, it doesn't count in the count, or the second page here doesn't count. For whatever reason, the page number starts here on this page. So you see page 1. Well, maybe. My computer froze. Okay, page 1. Then page 2, right? So we will start on page 15, which is page 17 in Adobe, right? Problem 4, right? That's where the assignment starts. But we'll actually go, because all this stuff before that is good information to help teach you about subnetting, right? It's not graded, but it helps you learn about subnetting and gives you examples and things, right? All right, so the first thing that we need to know, right, is we're talking with version 4, right? There is a version 6, but we'll get into that much later, and it's much easier in a lot of ways because we don't subnet, but it's harder because they're much larger numbers to deal with. But this is IPv4, and the first thing we learned is that there are various classes or categories of where we put our IP addresses, and it's based on the first digit of the IP address, right? So IP addresses consist of 4 numbers, right? Our IP addresses have 4 numbers between three periods, right? And so if the first digit is between a 1 and 127, it is in a Class A network. And what that means for us with subnetting is the first 8 bits of the 32-bit IP address. I guess let's go with that first. So each IP address has 32 bits. And what is a bit? 0 or a 1, right? It's binary math, right? So there's 32 zeros and or ones in an IP address. And they're divided as 8 bits for each number, right? So we have 4 numbers, so we have 8 bits in what's called an octet because it's got 8 bits. So we got 4 octets in an IP address, all right? And each octet has 8 bits, or 8 zeros or ones. A Class A is any IP address where the first octet, the number, equals 1 through 127. All right? If that's the case, then the first 8 bits of that IP address signify the network. The next 24 bits signify the host. Right? And that's what this is saying right here, right? Network ID and the host IDs, right? So the network portion for a Class A is the first 8 bits, and the host portion for the Class A is the last 24 bits, all right? Class B starts with 128 through 191, and it has the first 2 octets, or 16 bits, as its network portion, and the last 16 bits as its host portion, all right? And then Class C is 192 to 223, and it has the first 3 octets, or the first 24 bits are network, and the last 8 bits are for hosts, all right? Now, the Class D and E, they exist, but we don't use them for devices, right, as far as assigning IP addresses. So you can read there, right? So 224 to 239 is Class D. It's reserved for multicasting, and then 240 to 255 is reserved for research, right? We don't use them, right? But so the Class A, B, and C are what are most important to us. So we have public IPs and then private IPs. Private IPs we can use for anybody can use them. They're available for your private use. They can't be routed on the network, on the internet, right? But they're used internally, right? And we have one range for each of the classes, right? So we have a private IP space in the Class A range from 10.0.0.0 to 10.255.255.255, right? So that's a lot. It's like 16,777,000 something IPs, right? Because it's, well, let's just do this. Basically, from 0 to 255 is 256 IPs, right? So we got 256 times 256 times 256. What the heck? 256, my computer's running slow. All right, 16,777,216. Right, I did that because there's 3 octets with 256 available, right? So this one, and this one, right? 0 to 255. So I just multiply them, right? And that gives me 16,777,216 IPs available on that Class A, all right? The Class B, right, it starts at 172.16.0.0 to 172.31.255.255, right? So it doesn't start at 0, right? So 172.15, 0 to 15, they are owned by somebody. They're public, right? And then also 172.32 and above is owned by somebody. So you can only use the 16 to 31. But so if we wanted to do that, see how many IPs we have there, right? We have 256 times 256 times what? 16? What? Right, 16. About 1,048,574. But, however, with a class B, right, the first 2 digits are the network. So because the numbers are different, they're different networks. There's 16 networks, right? So we got to divide that out by 16. So we have 536 IPs per network. We've got 16 networks. Here we had one network with 16 million, right? This is 16 networks with 65,536 IPs. All right. And finally, we have the class C, right, is 192.168.0.0 to 192.168.255.255. Once again, all right, so class C, we have 3 digits, right? So we've got 256 networks with 256 IPs. Does that make sense to everybody? No? Okay. So because it's a class C, the first 3 digits, if they match, they're on the same network, right? So we've got 0 to 255, which means we have 256 different numbers or networks, right? And then we got 0 to 255 on each of those networks. So we have 256 networks with 256 IPs. Okay, let's see here. And then this is where our first subnetting comes into play, right? So when we said that the first 8 bits identify the network, we're really saying that we have a subnet mask of 255.0.0.0 for class A. So subnet masks, they also have 32 bits, just like an IP address. They have 4 octets, just like an IP address, but they're designed to help us take a single network and divide it into smaller networks, right? So by default, when you have a class A, B, or C, you have one network, and this is its mask. These are the default masks when it's one network. So an A has a mask of 255.0.0.0. A B has a default mask of 255.255.0.0. And then C is 255.255.255.0. And it just matches that the first 8 bits are network for an A, first 16 bits are network for a B, and the first 24 bits are network for C. So that's what it's doing. And if you take the 8 bits, right, so you have your bits going to range from, so you have 1 bit, you have 1, right? 2 to the 0 is 1, right? 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16. 2 to the 5 is 32. 2 to the 6 is 64. And 2 to the 7th is 128. But you add them all together and you get 255, right? Because 2 to the 8th would be 256. All right, so I actually get 256, but yeah. Anyway, so that you get these 255s when all 8 bits are set, right? So that's just saying that all 8 bits are set in the first 3 octets for class C, but then we can borrow bits from the host, right? Because remember, up here, we had the rest of any of these zeros are the host bits, right? So we have 24 bits on hosts for A's that we can borrow from. We have 16 bits from B that we can borrow from, and 8 bits from C that we can borrow from. And what we're doing is we've got a network, and we want to create more than one network. So we borrow bits. If we borrow 1 bit, how many numbers can we represent with 1 bit? Well, what are the numbers for a bit? 0 and 1, so there's 2, right? So if we borrow 1 bit, we can represent 2 networks or 2 numbers. If we borrow 2 bits, how many numbers can we represent? 4, right? So if we take 2 bits, we can create 4 networks because we can identify them with 4 distinct numbers. If you borrow 3 bits, you get how many? 8, right? And then if you take 4, right, you get 16, right? Then 32, 64, right, and so on, right? And like I said, we can borrow, we have 24 bits on a class C, so we can create a lot of networks, right? On a class C, or even on a class B, we have 16 bits, right? So if for example, we borrow 10 bits, how many networks can we create? What is 2 to the 10? 1024, right? 1024, right? So we borrow 10 bits, we can create 1024 networks. And say we are on a class B, right? So we have 16 bits, we borrow 10. What's that leave us? 6, right? 6. So then what is 2 to the 6th? 64, right? So we can have 1024 networks with 64 IP addresses on each network, right? And that's subnetting. So we'll get into it a little bit more. They have you learn about the bits, right, and how to add these up, right? You just add up the columns, right, and you get your numbers, right? So you can do the binary to decimal. I'm not going to do that tonight, but you can do that. Decimal to binary. Identifying your classes. I guess we can do a couple of these. All right. So what's 192?
C.
Right. That's the C. Right. Yep. Okay. 148. The B. Right. 193. C. Right. Okay. 126. A. All right. 220. C, right, C. Right, so you can go back up here, but yeah, I'm not going to go do the others because they'll start getting into D's and E's. But so C goes to 223, right? Okay, so there's that, identifying that. So identifying the network is essential so that you can know what the default mask is, because that tells you how many bits you have left to borrow, right? You got to know how many are actually there to borrow. This is identifying the host in the network. It's again defining which is the host network, right? Okay, here's default masks. All right, so 191. What's the default mask? Well, what class is that? What's the class for 191? B, right? So what's its default mask? Right. So yes, exactly. And so this one, 223, is a C, right? So 255.255.0. And what does that mean? What does that mean by having a class C? Means that we only have 8 bits to borrow, right? Well, and actually less, because you can't borrow all of them, because you got to have some left for the machines, right? Okay, so that's good. But you know this one, yeah. So yeah. So now you get to do the whole thing, and it's not optional. My other classes, it's optional. All right, let's see here. But you can see there's some instructions in here, how to do a lot of things. All right, here's a problem we'll work through, right? Let me see here. Okay. All right, so we have an IP address of 192.10.10.0, right? We need 14 subnets with 14 hosts. All right. So what class is this? It's a class C, right? Class C. All right. So that means we have how many bits to borrow? 8, right? Okay. So we need 14 subnets. All right. Well, I guess what's our default mask? Right. Okay. And we need to create this right now is a network from 192.10.10.0 to 192.10.10.255, right? So that's the network that we have. We have all these IPs right now, right? We have 256 IPs from 192.10.10.0 to 255. All right, everybody see that? But what they're asking us to do is we need to create at least 14 subnets. All right, so we have to borrow some of these available bits to make networks. So how many bits do we need to borrow so that we can have at least 14 subnets?
16, right?
Right. So you have to borrow up to 6. How many bits though?
4 bits.
4 bits, right? 4 bits will get us 16 networks, right? So we're going to borrow 4 bits.
4 bits.
And we had 8 bits, right? So if we borrow 4, how many's left?
4.
Right? So we got 4 bits left for hosts. All right. So we said we created 16 subnets. Right? 16 subnets because we borrowed 4 bits. That leaves us 4 bits, which how many IPs left then if we have 4 bits? 16, right? 16 total IPs. All right. Now, the trick here is for every network, you have an identifying IP, which is the first IP, and the broadcast IP, which is the last IP. So we have to subtract 2, right? So that gives us 14 usable IPs or available IPs. So we have to always subtract 2 from our total IPs because we have to have the network ID and the broadcast ID. So now what we've done is we broke this up into 16 networks. So the first network starts 0, and so that's its network ID, right? And so we go 16, so 92 10.10.15. It ends there. So this is network 1. Network 2 starts at 16, goes to 31, right? 32, 16 is 47. 48, right, and so on, right? So you see what I'm doing? I'm filling in, right? Each network has 16 IPs, right? So the network ID goes up by 16 each time, right? So, and so you could actually just do this and then subtract 1 and you'll get your broadcast, right? It makes it easy, right? So you're going to need to do that in the future because they're going to ask you like, well, what is the first usable IP on network 4? So what would be our first usable IP on network 4? Let's, just the last one, last number. 49, right? Because 48, this is the network ID, right? 192.10.10.49 is our first available, right? And then, yeah.
But you said it's sub. Okay, so it's not.
So then the last one is the other one you can't, is the last one usable?
Right, this last one, this one's not usable. This is the broadcast.
Okay, that's.
This is the
those are
network,
two.
right?
Okay.
So 33 and 46, right?
Okay.
So for network 3, right, 192.10.10.33 and to 46, we can assign to machines.
Okay.
32 and 47, we can't use. We use them, but we can't assign them to a computer.
They're
Right.
already used.
They're already used.
But
Right.
yeah.
Right.
Some of that from the video, he's talking about something like that.
Something like that. Okay. All right. I guess you guys could have seen this anyway. I was hiding. I was just trying to not have you read it. Yeah. Oh, and then the subnet mask. Right. So that's the one thing I haven't done. All right. So to get our subnet, our custom subnet mask, right? So, all right. 28, 64, 32, 16, 8, 4, 1. So we borrowed 4 bits, right? We always borrow the largest bits, the bits from the left, because all our networks, when you've seen our networks, right, they are on the left. Hosts are on the right, so we always borrow the bits, the furthest bits on the left. So we borrowed 4 bits. We add them together, 128 plus 64 plus 32 plus 16 equals 240. And then that's why we get our new mask of 255, 255, 255, 240. Okay. So let's do another one. But this time I'll do one that's not done in the book. All right, let's just go ahead and do number 4, which is on page 15. All right. Okay, so our IP address 195.85.8. Thank you. Yeah. Okay. So, and we want 6 subnets. Right? 6 subnets with 30 usable posts. Okay. All right. So we've got this IP address, right? This one network. We need to create at least 6 networks. All right, so what is our class? C, right? Okay, so we'll put that in there, class C. So our default mask, 255, 255, 255, 0, right? Okay, now the way I usually do these is I skip all the way down to the number of bits borrowed, because you need that to answer all the other questions, right? I don't know why they put it last, but they put it last. So how many bits do I need to borrow to create at least 6 networks? 3, right? How many networks does that create? 8, right? All right, so now if we borrow 3 bits, right? 1, 2, 3, plus 128, plus 64, plus 32. 224, right? So our new mask, our custom mask, 255, 255, 255, 224. So if we enter that in, right now we've got 8 networks, right? When we enter that in, when we put in our IP address in our machines, right, we break that up into 8 networks. The machines know, oh, this is 8 different networks, right? All right, so how many hosts, right? If we, how many bits do we have to start with? We had 8, right? Because it's a class C, right? So we borrowed 3. So how many are left? 5 bits left, right? So how many hosts can we do with 5 bits? 2 to the 5, 2 to the 5th, 32, right? So we got 32 IPs. So how many of them are usable? 30. Right? So now we've got 8 networks with 30 usable hosts, right? That meets our criteria. We needed at least 6 with 30, right? So now I'm going to do one thing here. So I'm going to do the usable or the ranges again. So we had 85, 8.255. That was one network. So now we've got 8 networks. So number 1 is 195.85.8.0 to 195.185.8.31, right? Because we got 32, 8.32, 95.85.8.64. 85.8.96, right? So this is 195 dot, oops, 85.8.63, 195.85.8.95, right? So we got this concept, right? We got all these 8 different networks, right? But if I have, let's say I have an IP address of 195.85.8.65 and 195.85.8.35, all right? Are these on the same network? No, right? 65 is on network 3 and 35 is on network 2, right? I would need a router to be able to talk between these 2 IPs, right? Even though before I did subnetting, if my subnet address mask was the original 255.255.255.0, these 2 can talk without a router. But when I add and subnet to 255.224, they are no longer on the same network, and they have to have a router to talk. That's what we do with subnetting. It's breaking it out into zones, helping with security, things like that, and other reasons. But that is why we're subnetting. We're creating these different networks, right? And then when you have different networks, though, you need a router to communicate. All right. Let's see here. Let's get into, I want to do one more here. Okay, here's one that's good. I'm not going to do all of it, but all right, the number of usable hosts needed is 60, right? So we don't know how many networks we have, but we only need 60. We want to maximize the number of networks and that. So here we've got to do it a little backwards. How many? Okay, so one, how many bits do we have to work with? What class is this? It's a class C. So how many bits do we have? 8, right? So we only have 8 bits. So how many bits do we need to get 60? 6, right? Right. So 6 will get us 64, right? So how many bits are left? 2, right? So that's all that we can borrow, right? We can only borrow 2 because we have to have 6 for the host, right? And so then everything else will fall into play. But you know, this throws a lot of students the first time because they try to solve for networks for host, and then they get all messed up, right? Because it asks for host first, right? Let's do, I think it's 42. Okay, I went to page 44, technically, I think, yeah, 40, yeah, 42 on the Acrobat, but it's page 40. So this /16, right, that, as we found out in one of our labs too, right, the slash tells us how many bits we're using for our subnet mask, right? So they're automatically telling you how many bits you've borrowed, right? Because this, okay, 10.0.0.0 is what class? A, right? How many bits do we have to borrow? 24, right? Because it's a class A. Our subnet mask is 255.0.0.0, right? We have 3 zeros or host bits, right? So octets, so there's 24. So we're borrowing, we're saying we want a network with 16 bits, right? So they're telling you, I want a 255.255.0.0 network, right? So how many bits did we borrow? 8, right? We had 8 originally, so we borrowed 8. So we borrowed 8, right? So if we borrow 8, how many networks can we create? What's 2 to the 8th? 256, right? Okay, so now this is where it comes up. So now, how many bits do we have left, right? How many bits per host do we have left? We had 24, we took 8, right? So we have 16 left, right? So now we've got 2 to the 16 available, right? Anybody know what that is? It's 65,536, right? Class B has 65,536 by default because it's Class B has we turned the A into a B, right? But we turned the A into 256 B networks. You see how we've done that, right? Because a Class C has like 16 million IP addresses. So now we've got 256 networks, each with 65,536 IPs, or 256 Class B networks, right? Class A is fun to work with because it's huge. You can do almost anything with it, right? But so you see that, but that's not the /16. So if it were /24, what would our subnet mask be?
255,
Right, 255, right? Because we take the first 24 bits. What I'll throw it at. What if we had a /17? What would be our network mask. 128, right? We took 1 bit, right, off the next octet, right? So, right, so then 18 is 192, 19 is 224, 20 is 240, right? You're just adding the bits, right? But that's all that slash means. It's what's my subnet mask? It's how many bits in my subnet mask. That's what the slash means, right? So hopefully that won't throw you anymore when you see a slash. It's like, oh, that's how many bits are in the network portion of it, right? Or it helps define that subnet mask. Oh, yay. So here's some where they get harder, right? They ask you, what's the 11th subnet range, right? So let's kind of do that, all right? So, so how many hosts are here? 34, right? That's usable, right? Okay, so our IP address, this was was 10, right? And we're creating it into 256 Bs, right? So our networks look like this: 10.0.0.0 to 10.0.255.255, right? That's network 1. Network 2 is 10.1.0.0, 10.1.255.255, right? 3 is 10.2, right? Because remember, class B is the first 2 digits, right? We've got 256 class Bs, right? So that's why this works like that. It just keeps going, right? So basically whatever number, so what is our 11th range? 10.10, right? Because it's just -1, right? Right. So it's easy to answer these, even though it's kind of large, right? Yeah. At least they didn't ask you. I guess we don't have any weird ones like the 255, 128, and then it just gets really ugly. But yeah. All right. So let's see. I wonder. So there's some with the host only. I will say that there are some aids in the back too. Let's go back here. Some of these will work for you, some may not. Let's go. All right, so I got some tables here showing the /24s, 25s. And they break up the networks. It might help some people, right? So there's this boxing method. It confuses me more than it helps me, but but I've had students say that was really good. It really helped me. So I mean, depending on the type of learner you are, you go at the back here and look at some of these. You know, they may help you understand what's going on. But that is our IP subnetting in a nutshell. You'll get more comfortable by going through it at your own pace. This was real fast. We'll go over it many times this semester, especially after spring break. So, you're not on your own. And definitely come and ask me for help, right? That's what I'm here for. But this is IP subnetting. There's a lot to it, but it's not hard. Right, the math in it is, can you multiply by 2? Right, that's really the hardest thing you have to do. Really, you may have to do it a lot. Like 2 times 2 times 2 times 2 times 2. But you can get there by just doing that. Right. As you do this, you'll just get you know it. Right. You'll learn it. The more you do it. Yeah.
I knew it really well.
You know it really well.
I knew it really
well.
well.
You knew it really well last semester, right? Well, you only did a portion of it. So now after doing the whole thing, you'll know it really well. I guarantee you'll know it at least by the time you're done with this packet, you'll have a very good understanding of it, or you should. Now, and don't feel bad. It does take students, most students, a lot of effort to get this the very first time, but once it clicks, then it clicks, right? You can kind of attest to that, right? It took you a little bit at first.
Yeah, my clicker's a little rusty right now.
Well, I know it may be a little rusty right now, but when we
Yeah, I
were
had to
doing
ask
it,
questions.
yeah, right. You have to ask questions, right? It takes a while for that light bulb to click on, but then when it does, right, you know, it flows really well.
Yeah.
Yeah, because it's not difficult. It's just not intuitive or what we are used to, right? So it plays with us, and so yeah. But some students, you know, they just second nature to them too. So, but that's rare. Most students, it takes them a while to get through it. All right, so that is our IP subnetting. So what we'll do now is do our review. So if you want to, we can go to the K drive and J Spicer folder and our ITNW 1425, which is our class, the first folder, and then the exam folder. There's an exam 2. Okay, and I just realized I'm probably going to have to upload this for my online class because they will want access to this as well. It would only be fair.
Wait, is this all the questions?
No, it is not all the questions. So this is, I just basically went into Blackboard and said, give me an exam, and it gave me an exam. So this could have been one of your exams on Wednesday because it just pulled out 50 questions out of the question bank. And so we'll just go through them tonight. But so this is just an example. There are more questions, right? That's why you have to go through the quizzes multiple times because you can't see all the questions just like this. I would have to do at least probably 3 exams before I would have pulled out all the questions, right? So yeah, so no, it's not all of them, but this is a good example and start, right? And so what we'll do though is we'll go around the room and at least have you read the questions. So we'll just start here, Jeremy.
Okay. NFC tags are very expensive and cannot be purchased blank, requiring them to be preloaded.
True or false?
False.
False, right. Okay, awesome. All right, number 2.
Which of the following layer 1 WAN technologies is not normally used as last mile service, but rather traverses multiple ISP networks, connecting these networks to the internet backbone?
Sonnets, yeah, A. All right, good job. All right, number 3.
Where are MPLS labels placed within a frame?
Yep, between layer 2 header and layer 3 header, A. Good job. All right, question 4.
Which of the following is an advantage of leasing a frame relay circuit over leasing a dedicated circuit?
You only pay for what you need.
You only pay for the bandwidth you require. Yeah, absolutely. Good job. All right, number 5.
The HTTPS HTTP secure protocol utilizes the same TCP port as HTTP port 80.
False. What port do we use? 443. All right.
In order to generate a public and private key for use with SSH, what command line utility should you use?
What? I think I heard it. C, right? SSH keygen, right? So C is the correct command line. All right, number 7.
When troubleshooting wireless issue, what statement is okay?
Anyone?
A, access points,
A.
use overlaying,
All right. A, access points that use overlapping channels can cause interference with each other if they're too close. Right, absolutely. It's good that they put that as A. Yeah. So once you find something that's true, right, you can stop.
The following is not a task that a VPN concentrator is responsible for. A, the VPN concentrator shuts down established connection when malicious traffic occurs.
Right, it does not do that. Right.
That'd be amazing.
Yeah. It would be nice if it could do that, but yes, it's another device altogether. All right, so number 9. Yeah, yes, Joel.
The virtual network computing uses the application uses the first platform remote from multiple protocol.
True. Right, that is true. All right, 10.
Under L2TP establishing a VPN tunnel, GRE is used to transmit L2TP's data frames through the tunnel.
No, false, false. Right, it's false. Right. Okay, number 11 in the back there.
In 802.11 data frame contains 4 address fields in contrast to the 2 address fields in 802.3. True.
True, right? Right. It has the 4 frames. Anybody know what they are? What do we have for the regular Ethernet? Destination source, right? So then wireless, what do we add?
Address.
Hmm?
Header.
Well, right, but it's the transmitter and receiver, I believe, or the next hop. I can't even remember the name for that either, but it's basically who's handling it, right, on the wireless side. So, all right, number 12.
ISDN connection type use 2 B channel and 1 B channel.
What's that? C, right. The basic rate interface, BRI, is the ISDN connection we use with 2 B channels and a D. That's great. All right, number 13. We'll start in the back over here.
Which type of DSL technology has people downloading upload speed maxing out at around 2 megabytes per second?
B, SDSL, right. All right, 14. Oh, we probably should have started up front. That's all right, yeah.
When using a site-to-site VPN, what type of device sits at the edge of the LAN and establishes the connection between the sites?
Gateway, right. All right. 15. No, it's
What special enterprise VPNs supported by Cisco devices create VPN tunnels between branch locations as needed rather than requiring constant static tunnels? It's gonna be dynamic multi-point.
dynamic multi-point VPN. Excellent. Yeah. All right. 16.
Which file transfer protocol has no authentication or security for transferring files? Uses UDP and requires very little memory use.
Trivial FTP, TFTP, D, right? All right. 17.
The statement regarding the use of bridge mode BNIC is accurate. Is it across the bridge?
No. It actually, this has no answer technically, because the answer is inaccurate, because it's B, the VNIC will its own IP. It's missing the word have, right? will have its own IP address on the physical LAN. So technically, there is no answer to this question because B is correct-ish, but it's not entirely accurate. So it is B, though. I'm sorry, I had to play with that. I noticed that. I was just like, that's just wrong. All right, 18.
Although MPLS can operate over Ethernet frames, it is more often used over with other layer 2 protocols like those designed with LANs, or designed with LANs.
True or false? True. True? Maybe? You think? True. It is true. You just weren't confident with your true.
Nope.
It's like, is that a question? Number 19.
Healing messages are a feature of what smart home protocol?
Z-Wave. Excellent. All right. Back up front, Jeremy.
Due to many vulnerabilities and a short key length, the WPA security standard was replaced with WEP.
False, right? That should become a strong false. All right. 21.
In a software-defined network, what is responsible for controlling the flow of data?
SDN controller, right, is responsible for controlling. So these exams are really bad. They give you the answer a lot of times in the question.
Right.
Yeah, well, I guess it does, but yeah. From what I've seen, don't overthink it. It's usually the answer. If you know, that's fine. But if you have to guess, go with the word that's in the sentence. Just saying. All right, so 22.
If you need to evaluate Wi-Fi network availability as well as optimize Wi-Fi signal setting and identify security threats, what tool should you use?
Wi-Fi analyzer? Yes. Yes, right. We use the analyzer to analyze the space, right? All right, 23.
How does the 802.11 data frame indicate how large a packet should be fragmented?
Yeah, this is part of all that.
The sequence control field?
The sequence control field indicates how packets will be subdivided. That's awesome. Great job. Yeah. I didn't expect that because that's some of that detailed information that they throw in a slide or that little. Yeah, that little chart. Yeah. Yeah, exactly. It's almost like asking what's on page 312 underneath the picture, right? That's kind of that question. All right, 24.
Which statement regarding the use of cable modems is not accurate?
What's that?
Is it D?
It is D. It's because most modems only work at the physical layer, but cable modems do work at layer 2. So that's right. Okay, 25.
The global system for mobile communication, GSM, utilize what technology to create time slots on a channel?
Time. It's time division, multiple access, right? Exactly. Guess, right? It's time slots with a time division. Sorry, it works. Until it doesn't, right? But I mean, most of the time it works on these. All right, 26.
Utilize an LED that emits light with shorter wavelength than red light.
False, right? That is false.
It's greater, it's not shorter.
Yeah, Longer, not shorter.
Longer.
Okay.
Well,
Good.
greater,
Smaller, right, yeah.
Use of certificate authorities to associate public keys with certain users is known by what term? It's going to be public key organization.
Infrastructure, yeah, thank you. Yes, public key infrastructure for 27. All right, 28.
On an FTE network, how is the fact that data gets it? It's online.
D, right, switches determine the optimal path between sender and receiver and then establish the path before transmission. So it's D. All right, good, great job. 29.
With the SIP trunk, what is the only limitation on the number of calls that can run at any one time?
B, right, the amount of bandwidth, right? Yeah, if you don't have the bandwidth, you can't have the call. All right, 30.
At what layer of the OC model does the 802.11 standards vary?
What's that? No. Network and above, they're the same, right? It's the physical layer, right? Yeah. All right, so 31. So how many channels does a T1 have? 24. I thought I heard it over here. Yeah, 24. So B, right? It allows it to carry 24 channels. All right, 32. Go on the back.
What is the data link connection identifier DLCI utilized for? D.
D, right? It's used by routers to determine which circuit to forward a frame to in a frame relay network. Excellent. All right, 33.
The C-band utilized by satellites.
Right. D, right? This is another chart, right? But D, 3.4 to 6.7 gigahertz is the C band. Yeah. All right, 34.
Which of the following statements regarding the 802.11ac standard is not accurate? It's D.
D, right? Right, it's not accurate that access points functions like a hub, right? Right, that would be horrible, right? All right, 35.
Why is the telnet utility a poor choice for remote access to a device? I think it's because it doesn't offer any encryption.
Right, there's no encryption for sure. It's poor authentication and no encryption. A, right? Yeah. Telnet is just, there's no reason to ever use it. All right, 36.
DSL signals travel over telephone lines using 300 to 3300 frequency ranges. True?
No, it's false. All right, no. Bonus points, anyone know what a range is? Because I had no idea. Yeah, but
It was a guess.
yeah, but it is not. Yeah. 37.
Which of the following regarding point-to-point protocol is not accurate?
Layer protocol? I guess so.
So it can do 3 of them, but it can't do 1 of them.
Can't do B.
B, right. It does not have strong support for encryption, right? Yeah.
I never got these questions.
Yeah. I don't like
These
the
must be
knots.
quizzes that I'm not getting.
Yeah. We got to take the quizzes more often.
Yeah.
How many times do I have to say it?
Yeah, I don't know. At least 5. At least 5, yeah, or more.
Get all the questions to you, just 3. On
Yeah.
test 1,
Yeah.
the day before the test
Yeah.
day, it's showing like really different the question, like more than 20 questions.
Right. Yeah, if you don't take the quizzes multiple times, you won't see all the questions, and that's why I hound on it constantly. Take the quizzes multiple times, because it's crazy. But you want to see all the questions. At 38.
But in public switch telephone network, lines are terminated at the central office. It's true.
That is true. All right, I'll take the last ones because there's not enough fare for everybody. All right, 39, right? The VMware Player and Linux KVM are both examples of what type of hypervisor? 2, right? It's a type 2 because you need an OS, right?
Type 1s don't.
Type 1s don't, right? They're called bare metal, right? All right. So 40, by default, what network connection type is selected when creating a VM in VMware and VirtualBox or KVM? What's that? That's not the default. What does it usually default to? NAT, right? All right. Okay, so D, NAT. All right, 41, when you're using the public-private keys to connect to an SSH server from a Linux device, where must your public key be placed before you can connect? It's kind of a odd one, but what? I think I heard it. D, right? In an authorization file on the host where the SSH server is. Yeah. All right. Which Bluetooth power class allows for a maximum power output of 100 milliwatts and a range of 100 meters? Class 1. Good job. Yeah. All right. 43. A fractional T1's bandwidth can be least multiples of what data rate? 64 kbs. Right. That's good. All right. How many data streams are used in 802.11ac Wave 2 devices? 4. That's great. Yes. A, 4 data streams are used in 802.11ac Wave 2 devices. All right. A type 2 hypervisor installs on a computer before any OS and is therefore called a bare metal hypervisor. False, right? That's a type 1, right? So they're trying to trick you. All right. 46. When using satellite services for your WAN connections, what statement is accurate? B, right, satellite service suffers more latency and jitter, or B, I need new service, right? Oh, but, yeah, so it's B, it's latency and jitters. 47, which of the following virtualization products is an example of a bare metal hypervisor? Citrix Zen Server is a bare metal hypervisor. All right, 48. What is the purpose of the Layer 2 LLC sublayer? Handling multiplexing, flow, error control, and reliability. Good job. Yeah, excellent. 49. In a public switch telephone network, what portion of the network is known as the local loop?
Remote switch. Business to residence nearest central.
Right, it's the portion that connects any resident or business to the nearest central office. B. Right, B is the answer for 49. 50. All right, what is not a potential disadvantage of a utilizing virtualization? Oh my goodness. What is not a potential disadvantage of utilizing virtualization? This one is an awful question.
Yeah.
So which disadvantage does not exist? A, right, virtualization software increases the complexity of backups, making creations of usable backups difficult. That is not something that is not a disadvantage, and it's not, my brain's exploding with this question. Who thought this up? All right. So that is an example exam that we will have on Wednesday, right? Why are we're not coming on Monday, right? No class on Monday. You can, if you want to, right, that's fine, but we'll have to do it online. But do log in online, and then take a quiz so you get attendance. But yes, sir. Sign-in sheet did go around today. It's up here in front. You can get it here. Make sure you sign in. Rest of the time is for the labs. So make sure you've got the labs, the WAN links. Lab web links is due Sunday. All right. All right. Thanks, sir.
Thank you. Have a good weekend.
All right, you too. All right.